Hi students, welcome to the video on analog electronics lab. In this video we will see the design of a few experiments that will be conducted in analog electronics lab. So let us start with the DC power supply design. So we are supposed to design this block diagram, this black box which will accept the AC signal and give a DC signal. So this is a 230 volt 50 hertz AC signal. This is the DC power supply what we are supposed to design. The output voltage can be plus 5 volt, it can be plus 9 volt, it can be plus 12 volt, it can be plus 15 volt, or it can be minus 5, minus 9, minus 12, minus 15 volt, or sometimes you need to have both plus and minus 5 volts. This is plus and minus 9 volt, it can be plus or minus 12 volt power supply, it can be plus or minus 15 volt power supply. Since it is positive power supply, negative power supply, this is dual power supply. This is dual power supply. So all these are no load voltages. So without connecting any load, I should be getting this constant voltage. So if you connect some load, actually a regulator, even upon loading, so till certain current, load current, the output voltage should be constant. So that's what is our design is. So but in the lab, so we try to just design a no load voltage of any specified voltage. So let us do the typical design of getting plus 5 volt DC from a 230 volt 50 hertz AC signal. So let us write a circuit diagram and then start designing the things. So let me write the circuit diagram which goes this way. Maybe before we write the circuit diagram, let me write the block diagram and develop the circuit diagram. So this is my input AC signal. This is the first block comes out to be step down transformer, step down transformer. Then comes the rectifier. Rectifier usually uses diode. It can be half-wave rectifier, full-wave rectifier, or it can be a bridge rectifier. Next comes the filtering. Filter, usually SC filter is used, and then comes a regulator. The regulator, usually an IC will be used, and this is your constant DC voltage. Constant DC voltage. This is what we are looking at. So let us fill all these blocks using the circuit components. Now let me write this is the primary of the transformer. Then comes the core. This is the secondary. So let us start with half-wave rectifier. Let me use this is my regulator. So this is 7805 because you are looking for plus 5 volts. So now it is 230 volt 50 hertz AC signal. So we are supposed to design the rating of this capacitance value, all those stuff. So let me write the waveforms at different positions 1, 2 and 3. At 3 we know we should have a constant DC voltage of 5 volt. This is at 3, and at 1 we have this input sine wave. Input sine wave, what you have is this, and at this point it's a filtered waveform. So let me write the input reference so that I can write the ripple properly. Sorry, so that I can write the ripple properly. This is what is that I'm having. So this will be slightly, this will be the decaying one, exponential decay. So now this voltage, let me call it as some Vx. Let me say this as V peak. Let me say this as V peak dash. V peak dash. So V peak and V peak dash, between V peak here and V peak of this. So I have a diode here. So I can write V peak dash is actually V peak plus V gamma. That is when diode is, whatever diode drop that comes here. So this voltage is this voltage plus the diode drop. That is the peak voltage. So what is this Vx? Vx is the minimum voltage you should maintain so that this regulator gives constant phi. So let us go back to this data sheet and try to find out what is that minimum voltage required. If you can see, this is 7805 electrical characteristics. This is your output parameter. So output parameter will be typically 5 volt when the input voltage is between 7.5 to 20. If the input is within this range, you are guaranteed of a typical output voltage of 5 volts. Sometimes it may go up to 5.25, or it can be as less as 4.75, but typically it is 5 volts, provided the input is in this range and the current is between 5 milliampere to 1 ampere. So you should not be loading too much of load to the regulator. So under such conditions, so you're supposed to get a constant 5 volt. So input voltage should be more than 7.5 but should be less than 20 volt. So now, since that's what we are talking about, what should be this Vx? Vx should be more than 7.5. So to have some tolerance, let us take this Vx as 10 volt. Let Vx be, because now we started designing, let Vx be 10 volt, because this 10 volt is certainly more than 7.5, what is required, minimum required here. So if it is 10, it is certainly always more than 7.5. So let us have a ripple voltage of around 2 volt here. So let this be 2 volt. So then what is your V peak? So V peak is actually Vx plus V ripple. Vx plus V ripple, which is nothing but Vx is 10, V ripple is 2 volt, it is 12 volt. This is 12 volt. How much is this? So this is V peak. How much is V peak dash? V peak dash is V peak plus V gamma. So it is 12 plus 0.7. It is 12.7. So I should be getting a peak voltage of 12.7. This is peak dash. So if peak dash is 12.7, then what is the RMS of this? The RMS of that would be, okay, if I find the RMS of that, so what is VRMS of the transformer? It is V peak dash by root 2. It is 12.7 divided by root 2. It is 8.98, which is equal to 9 volt. So if you use a 9 volt transformer, it will give you 12.7 as the peak voltage. Then you can comfortably get the voltage here. So now we know how much is what is the shape of the waveform that you're getting here. In order to get this ripple voltage of 2 volt, we should know what is the value of C. So we have an expression for V ripple, which is nothing but the voltage, the peak voltage of your capacitor, which is V peak divided by FRC, where F is the frequency of your input signal and R is the resistance that is seen here. So this is usually 1 kilo ohm. This is usually 1 kilo ohm. And C you are supposed to find. So since we are looking for a ripple voltage of 2 volts with a peak voltage as 12, with a frequency as 50 hertz, with the R is equal to 1 kilo ohm. So let us find the value of C. So then what is the value of C? So it is 2 alpha equals, open the parenthesis, 12 divided by, open the parenthesis, 50 into 1 exponential 3 into alpha A, close, shift cal. So I got the value of CS. So C is equal to 120 microfarad. So I'm getting value of C is equal to 120 microfarad. So it is better. Okay, let me assume, okay, even if the ripple voltage is less, it's fine. So now C should be minimum of, if C is 120 microfarad, and if the value of this R, which is the input impedance of 7805, if it is 1 kilo ohm, you'll have a ripple voltage of 2 volts. So what we'll do now is, so now maybe in the lab you have a C of 500 microfarad. So what we'll do is we will choose uh, a transformer of 909 rating, that is 9 volt 09. So this is what is my transformer rating, what I have. This is 909, and this is my primary. So now I will not use this, I will use a center tab. This is, I'll use a transformer, sorry, a diode, and let me use a capacitor of 500 mech, because 500 is a typical standard. This is 7805. If the input impedance, this is usually 1 kilo ohm, that will be, that has been measured. If this is 1 in 4005. So since you're using 909, so this is 9 volt RMS. So what is the peak you're going to get? So peak voltage is 9 into root 2, which is 9 into root 2 is 12.7. So minus, this is V peak dash. How much is V peak? V peak is 12.7 minus 0.7 is 12 volt. And how much is V ripple? V ripple, we know that it is this voltage, that is V peak voltage divided by F into R into C. Since I'm using a C of 500 microfarad, how much will this? It is 12 divided by 50 into 1 exponential 3 into 500 exponential minus 6. You can see now the ripple voltage is hardly 0.48 volts. If it is hardly 480 millivolts, how does your waveform look like? Especially the, so this is at 12 volt. From 12, so how much is this ripple? This ripple will be hardly 0.48 volt. If it is 0.48 volt, if it is 12, how much will be this? It is 12 minus 0.48, which is 11.52 volt. 11.52 volt is the input to this regulator. This is 11.52 volt is the input regulator, which will certainly give a constant 5 volt comfortably. So if you use a transformer rating of 909, you will comfortably get all the values perfect. So this is how you can do the design to get so and so. Suppose if you want to get a plus 12 volt power supply, again you just do the reverse engineering here. So let me just tell how much you want. If you just go back to data sheet and say see how much is minimum required for 12 volt. See here, this is for 7805. If you see for 7812, where is this? Let me just go back. This is for 7812. So 7812 minimum required is 14.5. So minimum required is 14.5. So let me just change this. Let me just write the waveforms only, so that you can easily change your specifications comfortably. This is another T, this is another T, this is what this is, let me write it as 14.5 to 27. Let me show you what's happening. So now I want to have a constant 12 volt. To get constant 12 volt, you should have minimum 14.5. So let us take 14.5 plus another 5 volt. So let me take around 20 volt as the magnitude. So if you have minimum 20, so this is what I'm talking about is this. So this is this is what I'm talking is 20. Let us have a ripple voltage of around maybe 0.5 volt. This is 20.5 as the peak. So how much is the ripple? Ripple is 0.5. So V ripple is 0.5 volt, Vx is 20 volt, and V peak is 20.5. So as per your, because I want to find the value of rating of the transformer, so then if it is 20.5, what should be the peak? The peak is another 0.7 above that. So this is 20.5 plus 0.7, it is 21.2 volt. So this is my V peak dash of the transformer. So then what's your transformer rating? Transformer rating is V peak dash by root 2, because usually the transformer ratings will be in the RMS voltage. So I'm trying to find the what is RMS of this. So RMS of that is okay, 21.2 divided by root 2. It is actually 14.99 volt RMS. If it is 14.9 volt RMS, maybe a 15 volt RMS. 15 volt RMS will comfortably give you. If it is 15 volt RMS, so this is okay, you can easily get. Then how much is the value of C? So you know that V ripple is equal to V peak by FRC. So V peak is 0.5, sorry, V ripple is 0.5, V peak is 20.5, and this is 50 into 1K into C value. So how much is C then? 0.5 alpha equals 20.5 divided by 50 into 1 exponential 3 into alpha A. Then C value comes out to be C is now 820 microfarad. 820 microfarad. Now this is transformer rating is 15015 volt. You can use center tap on one of the transformer, and capacitance is 820 microfarad required. Suppose if you go for 500 microfarad, what happens? So maybe a bit less. If you go for 500 microfarad, then V ripple will be 0.5 volt. If you choose 500 microfarad, then V ripple slightly increases. So it will be how much? It will be 20.5 divided by 50 into 1 exponential 3 into 500 exponential minus 6. The ripple voltage will be 820 millivolt. Instead of 500 millivolt, it will be 820 millivolt. That's not a huge problem. So from 20.5, it is less by 820 millivolt, which will be far more than 14.5 volt, that is minimum required. So now what you can choose is, for a plus 12 volt regulator, if you use a transformer of 15015, use a capacitor, use this 7812. This is again 500 microfarad. You'll comfortably get this waveform. This is 230 volt, 50 hertz. You'll get plus 12 volt. You'll get plus 12 volt. You can see this is plus 12 comfortably getting. So this should be, this is 1N4005, a rectified. Of course, the design simply changes. Suppose if you use a half-wave rectifier, what happens? If you use a bridge, what happens? Hardly no major change. Let me just tell you what happens when you use the circuit. Will be like this. What the circuit you're going to have? If you use a full-wave rectifier, this is my primary of the transformer core. This is the secondary. You'll have this. You'll have this. This is your, put the capacitor here. This is ground. This is 230 volt 50 hertz AC signal 7805. You can assume that you want to get plus 5 volt here. So let us assume that as we decided the previous case, how much was that? We actually wanted that to be how much we wanted. We wanted it to be uh, so this minimum should be 12 volt here. So if you want to have 12 volts, so this is the waveform what you're looking at. This is time. So this is constant 5 volt what you're looking for. This is the input waveform. This is the input waveform what you have, and this is how your capacitor charging discharging will happen. So this minimum should be, let us assume that this should be 12 volt, and if you want to have a ripple voltage of around 1 volt, then this is 13 volt, then this is 13.7. so let us see what happens. Only change from this to previous circuit is the circuit will change. How do we find the value of C? Now what is this? Is actually we named it as Vx. No, this is V peak. V peak. This is V peak dash. V peak dash. So what is V peak dash? V peak dash is 13.7. V peak is 13. Vx is 12. V ripple is 1 volt. So what is this expression V ripple? So why did you choose this as 12? So this should be more than 7.5 from datasheet. This is coming from datasheet. So why this is 1 volt? Because I should not have too much of ripple. This is 1 is equal to, it is V peak by FRC. In this case of full wave rectifier, it is not simply FRC, it is 2FRC, because this is for half wave rectifier. For full wave rectifier, you'll have one more waveform, then this will actually go like this. So that's why this is 2FRC. So this is due to another half of the cycle. This is flipped up. So when you have a half wave rectifier, it will go till here. So the ripple is more. The ripple will actually reduce by 2 times when you consider a full wave rectifier. That's why it is 2FRC. That is the only difference. So then what we have? So it is 1 is equal to V peak is 13 by 2 into 50 into, so R is 1K into C value. Actually the value of C comes out to be half than previous. So of course here we just taken for 1 volt how much is C value, you can find out. So whatever value that C comes, you can just keep that. So from that you work back, try to find out what is the RMS voltage that is required here. It is 13.7. This is peak, so RMS of that would be 13.7 divided by root 2 would be 9.6. So 9.68 volt is the RMS. You can use a 10 volt transformer. If you use 10 volt transformer, it will be sufficient. Suppose if you don't have 10 volt, even if you have 9 volt transformer, what is 9 into root 2? 9 into root 2 would be 12.7, which will be more than sufficient to get this, because 12.7 will give you 12. 12 minus 1 is 11. Still 11 is far more than 7.5 volt. You'll get a comfortable output voltage of 5 volts. Make sure that the minimum voltage of at the input of your regulator is always more than 7.5. As long as you maintain that, you'll get a constant 5 volts. So that's it about the power supply design. Then how to do line and load regulation, we'll see it in the so this is the value of C. Okay, let me just find out the value of C also. For this particular case, it is 1 alpha equals 13 divided by 2 into 50 into 1 exponential 3 into alpha A plus shift cal. Oh, something happened. This is, I think, only one parenthesis. shift cal. You can see now the value C is hardly 130 microfarad. 130 microfarad is the value C. For C of 130 microfarad data, you can get a comfortably constant voltage. That's about the power supply design. So in the next video we will see how do we design SC amplifier and CC amplifier. So this can be extended for even bridge rectifier also. Maybe if you want to see how does this will look like for a bridge rectifier. So for bridge rectifier, we know that this is a circuit what you have. This is actual circuit diagram. This is plus, this is minus of your DC. This is this primary of the transformer. This is secondary. The secondary, one of the terminal will go here, the other terminal will go here. This is 50 hertz, 230 volt AC signal. This is 78xx. You can think of whatever voltage to design the value of C. Again, what is, if you want to get 7815, which will give you 15 volt. Suppose in order to get 15 volts, how much the minimum voltage required, you can see here. You can just come down here and try to just look for that 78. You can see this is for 15 volt. For 15 volt, you need to have minimum 17.5. So let us take a minimum voltage of 20. So now I'm looking at this waveform. Now what I'll do now here is I'll take this as let this be VXP20 now. Let that VXP 20 volt, and let that V peak be 21 volt, so that V ripple is 1 volt. And since you have, of course, between this and this you have two diodes coming to picture, then V peak dash would be V peak plus 1.4, because there are two diodes. Only this is a change. So it will be 21 plus 1.4, which is 22.4 volts. So the rating of the transformer is 22.4 by root 2 is the transformer rating, which is nothing but, so how much is that? 20. Okay, why it is 22.4 is because 21 is the peak, and between this and this you have two diodes. You have two diodes, because here you can see two diodes will conduct during one half cycle. So if this is between this and this, you have two diodes coming in series. So that's why it is 21 plus 1.4, which is 22.4. So it is now 22.4 divided by root 2 is the rating. It is 15.83 volt RMS is the transformer rating. This is V RMS of the transformer. And then you can choose what is the capacitance value. Then V ripple is equal to V peak divided by 2F RC. So F is equal to 50 hertz, R is equal to 1 kilo ohm, V ripple of 1 volt will give you a value of C is equal to, I think that's what we found in the earlier section also. It is 1 alpha equals, it is 20. How much is V peak? 21. It is 21 divided by 50 into 2 into 1 exponential 3 into 5. It comes out to be 210 microfarad. If you use 210 microfarad and this is of 15.8 volt RM. You can see now there is no center tap required, so it doesn't require a center tap. It is 0 to maybe 0 to 16 volt transformer will give. Or if you are using 909, don't connect this 0. If it is between then this will be 018. So 018 will be comfortably suitable for this 0 to 16 rating. Fine. This is how you can able to use different rectifiers, different regulators to get a constant voltage. Okay, to do the load and line regulation, you can start putting some DRB, start with a very high resistance, start reducing resistance, observe the output voltage. To see the line regulation, take out this capacitor, you'll get a waveform something like this, you'll get it. So you try to know what is, try to put the cursors at different points and try to see how the if the input voltage is less than whatever that is minimum required, so output will not be stable, output will become constant only if it is more than 7.5 for 7805. It should be more than 14.5 for 12 volts. It should be more than 17.5 volt to get constant 50 hertz. So these are the different ways of different what parameter that you are supposed to find. One is how to regulate the output voltage, then it is load regulation and line regulation. Thank you.